Hello, students. You are welcome to session 4 of Unit 6. And in this session, we'll be looking at testing using quantitative terms. My name is Patrick Ej. By the end of this session, you should be able to explain the meaning of quantitative terms, give examples of quantitative expressions in science, state the advantages of using graph in testing, interpret a graph. So, communication in science. And to ensure accurate communication in science, all the sciences use mathematics. So, in the sciences, one of our languages, especially in physics, one of our basic languages that we speak most is the language of mathematics. And why do we speak this language? Because mathematics brings exactness to science, where vagueness once existed. And so when we describe phenomena, we may do so by use of dichotomous or metric terms. And a dichotomous explanation is of the type either or. So when we are saying either or, then a person can say that the ruler is tall or short. It is small or large, heavy or light. But you realize that this way of communicating is too vague. How tall is it? How short? How small? How large? How heavy or how light it is? So science tries to escape from such explanations because they are too ambiguous. What may be tall to one person may be short to another person. What may be heavy to you may be lighter to me. And so you realize that there is that ambiguity over here. And scientific explanations for that reason make use of the metric terms. So in the metric terms, instead of saying the ruler is tall or short, we can say that it is 1.6 meters tall, or the ruler has a length of 1.6 meters. And this gives us an idea as to whether it is short or tall. So instead of stating place some sugar in water, the scientists will be more likely to say that place 15 grams of sugar in 100 cm cube of water. You realize that the metric terms that were used here has given us an exact meaning, an exact understanding, and it has taken away vagueness. So in science, exactness is important for ensuring better communication and for replicating research. So it is the nature of the scientific community to have one scientist check the results of another, which would be impossible without the use of exact metric terms. So in the science community, you can conduct a research in one area, so let's say central region, and we can conduct the same experiment or research in Volta region to find out whether your findings in central is the same or there are some contradictions in the findings. And we can only do this when you give exact meaning. You speak directly. We're able to make meaning out of what you present. And you can do this when you present your data using the metric terms. So an example, let's consider this as an example. A non-quantitative explanation. A number of human beings suffering from cancerous growth were exposed to X radiations. The cancerous growth disappeared in a short time. Now this is a research, let's assume you conducted in your region. So let's say you are in Eastern region and you did this research and you've written this. You realize that it is too ambiguous. The cancerous growth disappeared in a short time. How long did it take for the cancerous growth to disappear? So for us to have some exactness, then we must have a quantitative explanation. So let's look at this example. And when we finish, we will compare the two to see which one gives us a better meaning and understanding. 40 subjects and 20 control patients suffering from cancerous growth were exposed to X radiations. On the third day, 30 of the patients no longer had cancerous growth. Which of these two examples gives a better understanding? Now you realize that the quantitative explanation gives us a better understanding of the problem. So to point out the importance of quantitative terms, A teacher can hold up a wooden cuboid in class and ask students to describe it so completely that it can be produced by someone who had never seen one. And how will this be done? Students often will write a description without giving exact dimensions. And so you as the teacher, you must discuss the necessity for giving the dimensions. You must emphasize the place, what these values stand when it comes to the use of mathematics in science. So once the student is giving this explanation and is mentioning the various dimensions, that a cuboid and the length is 12 centimeters, the breadth is 8 centimeters, and the width is the height is 15 centimeters. Once the person mentions this, somebody who has not even seen this before can completely produce an item which is in the form of cuboid having these dimensions that were being mentioned. So let's look at the use of graphs in testing. And graphing is one quantitative tool most frequently used in science. And the following are the advantages in using graphs. It gives tremendous amount of information in a small space of time. It helps the viewer to quickly see relationships which are not as apparent when one looks at a set of numbers. It gives pictorial representation of data, and this makes the data or information presented easily to be retained by students. So let's now interpret the data. An example. So we're going to interpret this kind of data. So let's consider this example. The graph below represents data collected on voltage. So this is the graph. The graph represents data collected on voltage V and current I in the laboratory during experiment on electricity. Now, we can ask the students questions like, from the data in the graph, what conclusion can you draw about the relationship between the voltage and the current? We can ask, what is the current I when the voltage V is 6 volts? What is the voltage V when the current is 7 amperes? Now, the student can look at this graph and generate or interpret this graph and provide us with a whole lot of information. Now, another way to teach students to use graphs is to use them and allow them to plot a graph when they are given data. And so let's consider this example. From the data given below, plot the graph of volume V of a gas in cm³ produced against time t in seconds. Now from the graph, find the volume of gas produced after 10 seconds. So this is another way of teaching students how to use graphs. Now students, in this session, we looked at testing using quantitative terms and the importance of using graphs in testing. Now as we bring the session to an end, what is meant by dichotomous terms? Give an example of the use of dichotomous terms. Students, I hope you enjoyed this session.